Thank you. So this is top 50 Java EE7 best practices. Several years ago I did a presentation on top 50 best practices for EJB, so this kind of builds off of that presentation. A little background, contact information for if you have questions after the presentation. We actually gave this presentation at Java1 this year. Michael was co-presenter on the presentation, so if you have questions for him or if I mess anything up during the presentation, it was probably trying to figure out his slides. A little background on myself. Michael and I were co-authors on the EJB3 in Action second edition book. So a lot of the content for this presentation was pulled from the book, so you can find some of the best practices that I discuss actually in the book, and hopefully now that Java EE8 is finally moving forward, hopefully we'll be able to get out the next edition once it's released. So as you know, Java EE is a huge standard and set of specifications. So the top 50 today, I'm only covering a small subset of them. So we'll be looking at best practices for web services for both RESTful and SOAP-based web services, concurrency, CDI, batching, JAXB, and JPA. For EJBs, if you search, you can find the presentation online for the top 50 EJB best practices. So it'll be a small subset of that, and at 50 minutes and 50, you'll have to do basically a slide a minute here. So first best practice, this one touches on JAX-RS, developing RESTful web services. From the start, you should build in versioning into your RESTful endpoints. So there's several different ways of doing this. You can do this with the URL by encoding the version number in the URL. So version 1 has v1 in this case. So retrieve for calling the RESTful web services v1 is version 1, version 2 is a separate one, and the reason why you should build this in at the get-go is because if your API is being used by mobile application out there and you have to rev the services, users do not necessarily always update their applications to the most recent version of the application, so there's a high probability that your RESTful web services will be hanging around for quite a while. So one approach is encoding it in the URL. The second one is either using media content or header parameters with that. That is an example of invoking one using a content type, using a media type to specify the version of the web service to invoke. And then with RESTful web services, for web services that have moved or changed, to return the corresponding HTTP code for 301 that is moved permanently, or 302 and provide the location of where the web service has moved to. So this is two different code samples. The first one is using URL, encoding it in the URL. So as you can see, I have meeting/v2 for version 2, retrieves the meetings. The second approach is using the media content types to handle implementing the versioning. And which approach you choose to use is up to you. And then this is an example of specifying, returning a message that the service has moved. So in this case, the version 1 has moved, and the user should, it'll automatically tell the caller that the service has moved to a new URL and provide that URL, and as well as the correct return type. Okay. Moving on, the second best practice is error handling. So things will go wrong, databases will be down, so you need to take that into account from the start. So in the case of here, what happens if the user does not exist? A user not found exception will be thrown and returned back to the client calling. Now, if it's a mobile application and you do not map your exceptions, what the client will receive is, instead of a JSON response, is an HTML page, which will then have to be parsed or somehow handled. So obviously, this isn't very useful for code that's calling it, because it'll have to deal with HTML. So the best practice is to provide it a exception mapper to map the exception and control the output. So in this case, I'm catching the exception matcher. Exception matcher is processing the exception and returning back JSON so that the calling code, the code that's calling it, can easily handle it. And it's much easier to handle in JavaScript. The next best practice is with caching. So if you have a web service that serves up data that doesn't change very often or changes infrequently, you can provide back basically a cache age, and the calling web browser or calling code can use this to figure out when it actually has to, retrieve a newer version of the data. So in this case here, I'm setting the max age to, I think that's seconds actually, 86,400 seconds. So if the calling client will know that it does not have to retrieve the most recent version if the cache is still valid. Moving on, the next best practice with RESTful Web Services is to combine it with bean validation to perform your checking. So to implement that, you add your annotation on your RESTful endpoint at valid, and the container will then check the object that's coming in, check it for the bean validation to verify that it is actually correct. So in the case of the code down here, you can see that the username must have 1 to 25 characters and provides a message if it's not provided, and then the email property that comes in should be a valid email. By turning on bean validation with your RESTful web service, you get the checking for free, and you don't have to actually implement that yourself and provide the coding for that. So this makes it much easier to write robust web services and reduces the amount of manual code that you have to write. The next best practice is to use compression for your RESTful endpoint. So in this case right here, I'm using a writer interceptor with the provider annotation to gzip the response going back to the client to save on bandwidth. This is important if you're dealing with mobile endpoints where you are possibly going over a slow network to compress down the response going back to the client. The next best practice with RESTful Web Services is to use tokens. So if RESTful Web Services are obviously stateless. So if every time you make and invoke a RESTful endpoint, you have to go back and perform authentication, that can be a bottleneck for your web service. So to provide some type of token on the call that specifies, this is the user authenticated session, and then the server implementation actually checks that and sets up the environment correctly. So in the case here, I'm actually using JASPEC to set up a JAS environment. So a token comes in, it then sets up the Java EE security so that security will flow through the application, and so that we don't have to do authentication every time a call is made to the server. And there are several different ways of handling this. The next best practice with JAX-RS is to use stateless and RESTful endpoints together. So your Java EE EJBs are pooled, so it gives you pooling capabilities with it, but also it gives you built-in transactions. So you're not trying to roll your own transactions as a part of it. This is especially if you're dealing with just web services. If you're dealing with a web service that's actually updating data, it needs to participate in a transaction. And then kind of tied in with that, you can turn on, many of the containers provide the ability to turn on tracing to trace the actual calls to find out what's actually going on underneath the hood and how the service is being invoked. The next best practice with JAX-RS is to use JAX-RS to implement an asynchronous API gateway. So in the case of this example here, we want to have you're going to call a RESTful endpoint that is then going to call other RESTful endpoints. So this is basically a composition of multiple microservices. So in the case right here, you can see on the get method, we have an asynchronous that then calls two other beans, which are also asynchronous, and returns future objects that we then later put it together and return the response back to the client asynchronously. So these are two other gateway calls that we're making, and each one of these invokes a remote microservice, which may take an indeterminate amount of time to actually complete. So the code right here just has sleeps in it in lieu of actually making the call out to the external service, and we can combine the results into a DTO and pass it back. Moving on from web services to JPA. So the first thing is to use pagination for potentially large result sets. So this is looks to be some trivial JPA code where we're retrieving a list of meetings from the database. However, if there are 100,000 meetings listed in this, or if you're retrieving a list of users and there might be 14,000, what you've just done is suck the entire database into memory. So you want to use pagination, especially when you're dealing with potentially thousands of records from the get-go. So this query right here would cause some scalability problems if there were a lot of records in the database. So this is converting it over to pagination, so we have basically our page size, the first result that we want to retrieve, and then we loop over working on a page of data at a time, so we don't suck the entire database into memory. Okay. A lazy relationship. So this is avoiding unnecessary queries. So if you have an object graph, you don't want to necessarily fetch all of the records every time you retrieve an object. So in the case of this code right here, we have a meeting, and a meeting has a list of speakers that are associated with it. So if common usage is to retrieve the meeting object to display the data, but you don't necessarily want to retrieve the speakers every time you retrieve a meeting object, so it is set on to fetch lazy type, which means that it will not, until we actually ask for the speakers, it will not retrieve them from the database. Now with that, so as you can see with the code, it'll actually execute two different SQL statements. So we retrieve the initial meeting object, and then when we ask for the size, check to see if it's empty or not. A second call will be made to the database, querying for the actual speakers at that point. So if we want to then collapse that down so that we only have one query, so with the fetch lazy, it'll of course execute, in this situation, execute two different calls, but obviously in many situations we don't want to do that where you call an is empty to find out whether you have any speakers or not. You don't want to execute another SQL call for that. We can actually pass in basically set a hint on the query on the retrieve mode of Wolf bypassing the catch. I'll get to that in a second. But we can actually set hints on that to retrieve the data. Okay, moving on to JPA Cascade. Don't forget to cascade levels to handle child data. So we have several different cascade options with it. All is equivalent to cascade, persist, merge, remove, and refresh, detach. So in the case of this code right here, we have a person object, and we want, when we perform the save, we want to cascade. So if we updated the list of addresses, we want to cascade all the changes down. So make sure to use the correct cascade type for the code that you're writing. The next is with entity graphs. So in the case of where we have a graph of objects and we want to retrieve the graph of objects, this is a feature with JPA 2.1. So we can actually set up and specify that we want to, we can specify that we want to retrieve a list. So, with the speakers here, so we have an entity graph, graph meeting speakers, that's going to retrieve that, and we can specify the hints when we go to retrieve the data that we want to retrieve the graph of objects so that it will only execute one SQL statement as opposed to multiple SQL statements when retrieving the object graph. So it reduces the amount of hits that we have on the database, the number of SQL queries that we execute. Now with CRUD operations, it's common to consider the entity manager to be basically your data access object. However, DAOs are still useful with Java EE7 in that when you combine it with CDI, you can actually switch out your persistence layer, your DAO layer for testing. So if you put all of your CRUD operations into DAOs, using CDI, you can then stub out that layer during testing to see what would happen if a SQL exception is thrown. How does that bubble up through your RESTful services? So you can use alternate implementations of your DAO layer to simulate different error conditions during testing. This is a well-known one with hashcode and equals. On your JPA entities, always implement hashcode and equals and make sure that they behave correctly. So the equals and hash codes are required for when an entity is added to a collection and also when reattaching entities to a new persistence context. Some important points, you do not want to use generated identifiers because those might be generated by the database and not be set yet, so you would not be able to determine equality if you haven't saved the object to the database yet. And you want to use basically something that's a business something that's related to the business key equality. So for instance, on a user object, you might use the username for determining equality. You know, is it the same user if the username is the object the same when you're comparing user objects based upon the username, not necessarily, you would not use the ID in the database or their address, as those things may change. So this is an example implementation of this, and I've actually used the IDE to generate the initial implementations and then gone in there afterwards and edited the code that it generated to match what the business requirements were. So, continuing on with JPA, with optimistic locking, don't try to roll your own solution for optimistic locking. You'll end up in trouble fairly quickly. Use the version annotation for optimistic locking, and you can use either a date or an integer. So in the case of this example right here, we have a version field, and so when it goes to update, it'll actually check to see whether the version that it's trying to update is the same version that's currently in the database, and otherwise it will throw an exception. So use the version identifier. Don't try to roll your own optimistic locking solution with that. And this is another example using a timestamp. So you've got two options, either integer or timestamp, whichever one you decide to use, it's up to you. With pessimistic locking, lean on the database for this. So there's several different settings that you can provide for this one. So you can see we have the hint where we set the lock timeout so that if there's a deadlock, the code doesn't get stuck forever. But in the event of using pessimistic, so the previous example was optimistic locking. This one is pessimistic locking. Don't try to roll your own pessimistic locking. Lean on the database and use JPA to provide that for you. Now, when reading through the EJB3 in Action book, we go over several different ways of mapping objects to the database. So you have to be careful when reading that chapter, as in you don't want to necessarily replicate your object model in the database. The approach that you take can have significant impacts upon database performance. So there are three different approaches: a single table, joined table, and a table per class. And each one of these has different performance characteristics with it. So a single table will obviously give you the best performance, but be more complicated to work with. Join tables, and then a table per class. Join tables actually is probably, I think, the worst performance, because you'll have, two classes for the subclass and then one join table. So every time you do a query against your data, every time you do a query, you'll actually be doing table joins. So you want to take that into account with it. So in the case of right here, I'm using a single table strategy, which will give pretty good performance versus the joined table approach. The next one that many people are not familiar with, many developers are not familiar with, is that JPA2 introduced caching. So with caching, JPA will actually cache the object behind the scenes for you. So if you've ever updated the database and then done an update but then didn't see the updated entity, the entity with the updated value, that's because JPA is doing caching behind the scenes. So it's for entities that are frequently read but not frequently updated, and that it's not critical if it's stale. So the important thing is that it's up to the implementation, the JPA implementation, to decide which value is the default value. So if you haven't checked this setting yet, you should definitely take a look at how your JPA configuration and what your shared cache mode is actually set to by default as for what you're doing. To ensure that you're not, so if you're working with an entity that is frequently updated, you will probably want to have it excluded. And then with the settings, so you have several different ways. You can have it always, you can have the shared cache mode always, never, and then enable selective or disable selective. So in the case of right here, you can see I've annotated this class with that it's cacheable. And then that's a programmatic way of doing this, for saying that this class does not change that often, so we want it in the cache. And then for situations where we want to bypass the cache, we can actually pass in a cache retrieval mode bypass, so that JPA will actually go to the database and retrieve the most recent version. It won't try to work with a cached value in memory. The next one with enumerations, Java, of course, has this great new enumeration feature that's been added in there for several years. So you do not want to try, with your data model, dumb down your data model so that you're working with constant strings. You can use enumerations. To do that, you'd use a converter, implement a converter, to convert your enumerations into the representation that you're using in the database. So in the case of this one here, we have a phone number type and a converter attached to it, which will convert it into a representation for the database. So in the case of this example, it'll actually convert it into a string, into a string to be stored in a var field with type underscore and then the lowercase representation of the enumeration. And on the return trip back, it'll convert it back into the correct Java enum. So keep your data models rich. Don't try to dumb them down for the database and use converters for enumerations. The next thing is with transaction handling. EJBs exist to handle transactions. Keep them at the right layer. So in the case of this example right here, so JAX-RS endpoints, you use JAX-RS endpoints for database reads. So you would not need transactions to turn on transactions if you're just doing simple reads on data that doesn't change that often. In the case of this code down here, this is basically demonstrating that the transaction type is not supported, so we don't want a transaction in play, and it'll actually throw an error if there was no error, if there was no code of transaction in place. Moving on from that one, EJB stateless thread safety. So remember that stateless EJB beans are pooled, which means that you should not be attempting to store state in them. And also, the pools are configured by the application server. So in the case of Pyra, there are 25 instances of a given stateless bean. So depending upon your application, you might actually have to change the size of the pool to achieve the performance that you're trying to get. Because if you have a limit of 25 EJB, if the initial pool size is set to 25 or the high watermark is set for 25, and 100 requests come in, 75 of them are going to sit there and wait for resources to free up for a bean to become available. So make sure you size your pools correctly and don't save state in them. The next best practices is with code that you want to kick off and run something asynchronously. So with EE7, the asynchronous tag was introduced, which allows you to, you place it on the method and the container handles spawning a separate thread for you and executing that task in a separate thread and then passing the result back via the future thing. Now the container is actually managing the thread pool, so if you have 100,000 requests come in, you won't end up with 100,000 threads. It'll bound them and ensure that it pulls them out of a thread pool. With EJB security, don't try to reinvent security yourself. Use declarative security and let the container handle it for you. Avoid programmatic security wherever possible. EE servers, Java EE servers have principal roles passed between, and this ties into the example earlier that I gave for JASPIC with your token-based web services. So if you use JASPIC, you can then tie the tokens back in to recreate your Java EE security context for making calls coming in from a RESTful endpoint. So in this case right here, you can see that we declare what roles are allowed, what roles this class will use, and then on the methods we specify what roles are allowed to actually invoke that method. And the container will handle ensuring that role, that the user has that role and can actually call that method, so you don't actually have to implement the security yourself. So the EE configuration, you're configuring it in web.xml or via the declared roles and roles allowed. And then there's mappings between what your applications provides and what the container is using as roles, so that goes into your deployment descriptor. The next one is avoid lengthy initialization. So a common code snippet that I've seen is you have a startup singleton EJB that initializes your application on startup, sucks data out from the database, initializes pick lists, etc. So say you have a initialization code that takes a long time, say 20 minutes. This can actually, if the application server is starting up, slow down the deployment of all the other applications. So if you have something that sits there and chews on data for 20 minutes to get you during deployment of your application, and the application is set to auto-deploy when the container comes back up. All of the other applications on the container will wait for that application to finish chewing through the data. So if it takes 20 minutes, all the other applications will have to possibly wait 20 minutes to start up, because generally the containers on startup deploy one application at a time in sequence. Okay, so this is an example here. This is where the asynchronous tag that asynchronous support that we looked at earlier comes into play. You'd still have your startup singleton, but it would call a method that would asynchronously initialize your application. Of course, you'd have to have fallback code that if somebody starts trying to call stuff that isn't initialized yet, it could handle it properly. But do not slow down the container startup by putting something in there that takes a long time to start up. Now moving on to CDI. CDI event observers allow you to write decoupled code. So it allows you to basically fire events within your EE application and not have tight coupling. So it is a very good thing to use. So in the case right here, we have an event object. So we have, a new order event has come in. So this represents the event. And so we have an order processor right here. So we inject basically an order complete event. And then we have an observer down below which observes that. So this code up here, it allows us to decouple the firing of events in the listener, so that in our EE application we don't have to write coupled code with listeners tied to implementations. So when an order processor comes in and receives a new order, it fires an event, and then some other class somewhere else in the system can receive and process that event. So it allows you to decouple code and reduce code dependencies. The next one is with CDI with code producers and a cache. So you can use a producer to customize the creation of an object. The producer method is always called, so you can actually implement caching this way. So in the case here, we have a complex object that we create that takes a while to create or is hard to create. So using a producer, we can actually cache the value and then return a new instance of it if it hasn't been initialized yet. But this allows us to control generating CDI beans. Moving on with interceptors, so we want to limit cross-cutting concerns. With interceptors, with CDI interceptors, you do not want to try to change business logic, so you don't want to try to change the result that's coming back from a method. What you want to actually do is interceptors are meant for implementing things like logging or cross-cutting concerns, not to actually override business logic or what a method returns. So I've seen quite a few cases where developers have abused this to try to change the value that's being returned or try to extend the business logic. Do not do that with interceptors. So using interceptors is pretty straightforward. You first create an annotation, and then you specify on your interceptor the annotation so that it'll know which one to hook up to it. And in this case right here, we're doing an around invoke, which allows us to intercept what's being invoked. And then actually using the interceptor, we add an annotation to the class. So in the case of this interceptor right here, this interceptor will actually retry calling the method if it fails the first time. So if the first call fails, it'll try recalling it again if an exception is thrown. Kind of an interesting use of an interceptor. Decorators are meant to enhance existing code. So in decorators, you can actually change something that's being returned. So whereas with interceptors, you should not be altering business logic, CDI decorators you would use for changing or enhancing what the code is actually being done, closing out resources. So in this case right here, we have a decorator that is making a copy of the data that's being returned back, so you're not working with the original values. That's an example of a decorator. And with decorators, you can configure them and change them in the beans.xml configuration file for CDI. The next one is with CDI2. We have the introduction of the transactional annotation, which allows us to use transactions and non-EJBs. Where this comes into play and where this is useful or best practices is in RESTful endpoints where you're just reading data out of a database and where it's not necessary to call an EJB to perform something. So in this case right here, we're saying that this method is transactional. So it's easier to utilize transactions outside of EJBs. The con, however, is that you're mixing layers. So in this case right here, we're mixing transactions and the RESTful endpoint layer, which actually makes the code ultimately harder to maintain, faster but harder to maintain. The next best practice is with Java EE7, CDI is enabled by default. So the bean discovery mode, there's several different bean discovery modes, annotated, all, or none. The default is annotated, so if you're upgrading an application from EE6 to EE7, realize that it can't find your beans or is instantiating the wrong version of the bean, you want to look at what your configuration is for this, and you probably want to explicitly set this in your beans.xml file so that you know which setting that you're using. So the default mode is annotated, so it will only create CDI beans that are annotated, whereas many Java EE6 applications were possibly written with all as the setting. Now with batching, use the Java EE batching support that was added in EE7. Don't try to roll your own batching implementation. And tied in with that, we have cron-like scheduling capabilities with EJB, starting in Java EE6 and 7, which allow you to specify when a job is being run. So in the case of this example right here, we're kicking off a batch job every 5 minutes, do some processing, and it is non-persistent. So don't try to roll your own batching solution with your own threading to manage it. Use what's built in with Java EE7. Now, best practices for deploying and packaging your application. Package and deploy batch jobs separately so that if you are using the Java EE7 batching API, package those as a separate WAR file and deploy those separately, because you possibly will deploy them out on different application servers. You don't want to always have every instance of your application doing batching as a part of it. Implement logic to do cleanup of old jobs. It's kind of interesting, the Java EE batching implementation doesn't actually have an API for cleaning out old jobs, old persistent jobs from the database, so that would actually, you either have to use an implementation specific version, or if you're working with the reference implementation, implement it yourself. Implement logic for auto restarting. Configure the database to store the jobs. So if you're using the Glassfish or Pyra application containers, it's actually using a Derby database underneath the hood by default. If your company is standardized on Oracle, you're going to want to use the Oracle database. Use the Oracle database that you're using for everything else. That also gives you visibility and control over backups. So if you're using the Java EE7 batching, but you haven't configured your data store for your container, it's possibly storing the persistent jobs in the installation directory of the container, which means that if your system goes down or you have disk corruption or something like that, it might not be a part of your nightly backups. Make sure to configure thread pools for batch jobs so it's not coming out of the one for other parts of the container, and only invoke batch jobs from logic that is secure. The Java EE7 batching doesn't tie into any of the security stuff, so it's up to you to make sure that whatever code kicks off a batch job is actually secure and security is being enforced. Moving on to JAXB, make sure that you know your data types, especially when dealing with using JAXB with SOAP web services to communicate with other types of technologies such as .NET. You actually have to know what the consumers of your web service, what data types they support. So as you can see in this case right here, we have the safe ones are highlighted in green. And then tying with data types, use the XML Gregorian calendar for dates. If you do a search on this, you'll see tons of people are having trouble or constantly trying to use Java util date. I'm getting very frustrated with the JAXB. And there's reasons for doing this. XML Gregorian calendar handles long fractions of a second, and this is important to .NET interoperability. So when working with web services, make sure to start out make sure to understand, just don't use the default, don't take your existing Pojo, add some annotations to it, and then hope that it will work with a .NET client. So this is an example right here where I've actually gone through and annotated the class. So don't let JAXB generate everything for you. Make sure that you know what it's generating and whether it's compatible with other platforms like .NET or other client types. With RPC versus document encoding, you've actually got several options with this. The default and most commonly used is document literal. So you do want to use document literal. You don't want to switch it to one of the other types. RPC literal is limited to basic XSD types, and the WSDL will not contain type section to constrain the parameters. Also, with the different types encoded is not supported by the WSI1 specification. So with JAXB, one of the things you have to be careful about is using it to, it'll happily serialize your entire object graph. So if you're writing an application in Glassfish with Metro implementation, with Metro Web Services, and you're returning back a race object which has a list of users, and it's got, you know, collections hanging off of it, along with the passwords, and you're using JAXB, it'll nicely serialize your entire object graph and send that back with the list of users. So you have to make sure that you know what your JAXB layer is actually serializing. So although it's extremely handy, you just throw some annotations on it, will, you know, convert your code into JSON, whatever. You know, do you know what it's sending back? Did you send back your entire database to somebody that made a call? Somebody asked for a race, called a RESTful endpoint to retrieve a race object, and you sent back the list of all the race participants with all of their passwords, because the code happily went through and serialized everything for you. So to get around that, you can either use use data transfer objects. So for code that you're going to use for serialization to JAXB, make sure to use data transfer objects where you know exactly what you're serializing, or add the XML transient annotation to parameters that you don't want to actually have serialized. So in this case here, you'd add it to the definitely to the password, possibly to the collection, so it doesn't serialize the entire object graph on you. With writing SOAP JAX-WS web services, SOAP-based web services, design the service starting with the WSDL. Don't start writing the Java code and then have it generate the WSDL for you. Always start with the WSDL. Create data types using the XSD. Keep the data types simple so that they can easily move. So if you have like a .NET client calling your service, that'll be supported. Avoid the XSD any type that's very hard to use with code generation. Avoid sending null values, as different platforms treat that differently. Use array of bytes instead of a Java string when the character encoding is unknown. Moving on to SOAP. Model exceptions explicitly thrown by the business logic, so you want to map in what exceptions your code could actually could throw. So make sure to handle SOAP faults correctly in the code, and specify. So in this case right here, I'm annotating this invalid purchase order as a potential web fault, and specifying the name and also the target namespace for it. Use SOAP message handlers to pre- and post-process messages and handle SOAP faults. So in the case right here, I'm binding, so I have a JAX-WS endpoint, a method that's being invoked and throwing an exception, and then I specify down below in the configuration a handler to process the message that's coming in and going out of this class. And implementing a handler is fairly straightforward. You implement the SOAP handler so you can handle the message, you can handle the fault, handle the close, and you can also get control over the headers that are going back and forth. So it allows you to pre and post process messages. With JAX-WS security, you can specify using the Java EE security, you can specify the security roles that are allowed to implement your web service. So don't try to roll your own security with SOAP-based web services, and make sure to specify roles so that the container can enforce them and ensure that you know who's actually calling your web service. If you're handling large blocks of data, use message transmission optimization mechanism, MTOM, to handle large files. So in the case right here, you can see I'm using MTOM, and I'm returning back a large, receiving a large file upload and then streaming it out to disk, so that I do not keep it into memory. So if somebody uploads a 5 gigabyte image, it doesn't keep it in memory. Doesn't keep it in memory. It streams it immediately out to disk. Deployment class path. This is one of my favorites. Do you know what you're pulling in when you build your your WAR files and deployment artifacts. So if you're using Maven and you specify a whole bunch of Maven dependencies, are those dependencies set up correctly, and do you know what you're actually packaging? Do these jar files contain or include Java EE annotated classes? So I've seen situations where somebody's pulling in a third-party package. That package has web services that are annotated with it. They're pulling that into their WAR file, and the container sees those annotations and deploys those web services, and the developer doesn't realize that they've actually deployed some web services from a third-party package as a part of their application. So all kinds of interesting things that can happen when you do that. Also, are you accidentally deploying, are you including container dependencies? So I can't tell you the number of times I've had to debug very bizarre container behaviors where the container's complaining that it can't find Mahara, or that it's trying to use something from Apache, and or something from WebLogic, and what's turned out is that somebody's added in a dependency for the WebLogic implementation into the compile class path, so the application is being deployed to, say, TomEE, and they're including the class path from WebLogic in it. And so the container's getting all confused because it's seeing a completely different implementation of, say, JSF with it, or a completely different implementation of the JMS provider. So make sure that you're not deploying, container dependencies as part of your application. So if you're deploying a application to Glassfish, don't include the Glassfish Java EE implementation classes in your WAR file, because bizarre things can start to happen at deployment time. So make sure, so in the case of right here, you can see I have a web application, and the web application includes within it the Java EE, one of the Java EE API classes. So we have faces, inject, interceptor, API, JMS. So you don't want to see API classes or implementation classes on the class path of your application. In fact, I think that should actually be a part of the build process that you scan to make sure that you don't accidentally package up container implementations in your WAR file. Never create threads manually in a Java EE application. That's something that's said in the specifications. You're not supposed to be doing your own threading. And the reason for this is that the container doesn't control the threading at this point. So if you have 1,000 calls coming in, and each one of those calls is creating a separate thread, you have a resource load on the server that you may not be aware of, or that you cannot control or monitor from the server. So you should be using, first of all, you should not be doing that. So in all of your EE code for EE applications, you should never see code that says new thread. You should be using, for instance, the managed thread factory to actually execute jobs in a separate thread that have to be multi-threaded. And the reason why is that the container now is managing the resources for you, which is the entire reason that you're using a container, is to manage the resources so that you know how many threads, so that you control the number of threads that are being created, the number of database connections that are being created, etc. So you're controlling the use of resources, and you can handle, and your application can correctly scale. The next thing is the singleton annotation. I've seen cases where this is used where some people have thought that this is a global singleton. It is not. It is a singleton for a particular instance of your application. So if you have your application load balanced across different servers, and you're treating a singleton as being a singleton across the entire application, it will not actually work that way. It's a singleton for each one of the Java EE servers. You'd use basically a JCache implementation, like something like Hazelcast, if you wanted to actually have singleton data that's accessible and in memory across all of your applications. So don't treat the EJB singleton as a global singleton, because it may work okay as a developer running in one instance of the container, but as soon as you get into a load balanced environment where you've got multiple containers running, it's no longer a singleton. Load testing, always at a 100%. This is a favorite one of mine for testing applications. Just because your application can handle 100% load doesn't mean that it actually can scale correctly. So in this case right here, I have a message-driven bean, and I've forgotten to implement some code in the cleanup, so I forget to clean up a resource. And so you test the application at 100% load. You load it up with 10,000 messages, and you keep it busy all of the time. The application will work perfectly fine. Now, if you vary the load of the application where the load fluctuates, the leak will actually continue to grow. So if the application is always busy, you won't have a leak. If the load on the application fluctuates, you end up with a leak. And the reason for this is with EJBs, you have the max pool size, you have a standing pool size, and you have an initial pool size for your beans, correct? So if the application is always busy, and the initial bean pool is set to 25, the application, it'll score if it's always loaded, you'll always have 25 beans and it will never destroy any beans. But if you have fluctuating load, it'll go up to 25 beans and then it'll drop back down to your standing pool size, which say is 10 beans, right? So every time you'll lose X, in this case right here, you'd leak 15 connections every time it dropped back down to the standing pool size. So it's important to test your application with enterprise applications with fluctuating load, not just trying to overload it to make sure it can handle, a maximum load. Testing integration. So for testing, use best practices to use a library such as Archillion to do testing, and this allows you to actually test within the container. So if you haven't checked out Archillion yet, definitely check it out. So in this case right here, I'm actually building up a application. I'm only building up a subset of the application because I don't want to deploy the entire application as a part of the tests, and then the unit test is actually running inside actually fires up the Java EE container, deploys the application that I built in that shrink wrap block of code right there, and then I'm able to test web services. I'm able to call EJBs. I can do all sorts of testing of the application running in the container using container resources. You can use this with the example that I did before, best practice before, with using CDI and DAOs. I can actually stub out the data access layer. When I build up the virtual war file there, specify different implementation of the DAO level, and then I can do a test call to web service and see how the code blows up if there's a failure. How does that get propagated back to a RESTful endpoint if there's a SQL exception? The next best practice is to actually look over the Java EE specification. It's, I think, 908, the current version of it is 918 pages. Look over the TOC, which is around 30 plus pages, and this highlights how much there is in Java EE and also what is available for you to actually use. Very often, you won't realize that Java EE provides a certain feature for you that it does have capabilities for threading. So just becoming aware of everything that's a part of Java EE so that you don't go out and reinvent the wheel. You don't try to reinvent your own security. You don't reinvent threading. You don't try to reinvent like the CDI event, event observers, etc. The next best practice, there are no small applications. Don't fall into these traps that, the application that you're working on is just a simple application. It only needs to do something really small. You can code it up quickly, deploy it in Tomcat, because Tomcat is not a Java EE container. The EE specification exists for a reason. It takes into account concurrency, multi-threading, transaction management, external resources, messaging, etc. So your small little application will eventually grow. And if you started it out on the wrong track with hacking up little blocks of code to get around things that that the EE provides for you, you'll actually end up reinventing the wheel and end up with spaghetti code. So tying in with that, because there are no small applications, start with an EE server from the start. Avoid filling up your WAR file with EE features. So I've seen it where somebody started off with a simple application in Tomcat. They needed messaging, so they added in a JMS provider. And then they wanted CDI, so they grabbed a CDI implementation. So they kind of basically in the end ended up building their own EE container, whereas if they just started with an EE container at the beginning, it would have saved them a lot of time. Although the perception in the past that servers are heavyweight, that's not exactly true, because they only start the features that your application is actually using, and most of them start up fairly quickly. So stick with a Java EE container. Don't try to roll your own application that you're then going to have to support, because with Java EE, they've tested all of the features working together. The next thing is to join us with Java EE Guardians. Java EE Guardians is a group that we're trying to actually keep Java EE moving. So feel free to join our distribution list and sign our petitions to keep Java EE moving forward. There's been some concern over the past year about progress with Java EE. So we're actually trying to keep the Oracle honest moving forward. And with that, I don't know how I'm doing for time. So I can take any questions if anybody has any questions. Questions? Okay, I think it's lunch. Thank you. This was hard to give without speaker notes.